notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC examination 2018 to 2027. Schedule of videos. Section 1, number theory and computation. All 33 of those videos have already been published in their entirety on YouTube. Section 2, consumer arithmetic. All 12 of those videos have already been published in their entirety on YouTube. Section 3, sets. All 6 of those videos have already been published in their entirety on YouTube. So all 51 of those videos have been published in their entirety on YouTube. We continue with section 4, measurement. This is the second of 16 videos, and then by end of January 2025, statistics. End of February 2025, algebra. End of March 2025, relations, functions, and graphs. And then April 2025, geometry and trigonometry. And finally, by May, mid-May hopefully, 2025, vectors and matrices, and that will take care of all the objectives in this syllabus. Reminder again, section 1, I have divided into 33 videos, and they are all published on YouTube in their entirety. This section forms the foundation on which the rest of the syllabus is based. How well you can handle this section, that is section 1, will predict how well you will do with the rest of the syllabus. So these videos here, all 33. So please make sure you look at them and know them well. Another reminder, if you don't already know the times tables 2 to 12, you will need to learn them, especially in the light that calculators are not allowed in paper 1. So as I said, section 2, all 12 of those videos have been published in their entirety on YouTube. And section 3, all 6 of these videos have been published in their entirety on YouTube. So a total of 51 complete videos based on all the specific objectives from sections 1, 2, and 3 of the CSEC math syllabus have been published on YouTube in their entirety. Section 4, measurement. So far, this one video has been published in its entirety on YouTube. So I am now at video 2. This one will not be published in its entirety. We continue here, objective 1, with part B. In the last video, we did part A, length mainly, length, and a little bit on mass. After we finish with those 4 objectives, there are 5 more on this page. And then finally, there are 6 more, and that will take us to 15 objectives, which is the end of section 4, measurement. Part B, objective 1. Convert units of mass area, volume, and capacity. That is what we will be doing in this video. Let's begin with mass. We did a little of this in the last video. The SI unit of mass is the kilogram. That's the SI unit. Note that this already has a factor of 1,000 since kilo means 1,000. For the purpose of this objective, we will use the gram as the base unit and apply those prefixes in the normal way. The most commonly used units of mass are the gram, the kilogram, and the ton. And then on smaller than the gram, you have the milligram and the microgram. So these are the prefixes that we have to learn. Please keep in mind that this mega here, if we deal with megagram, we are dealing with a ton. So as I said, we will use gram here as our base unit. As you go up, the units get larger, and as you come down, the units get smaller. So note that 1 ton is equal to 1,000 kilograms. So technically, 1 ton is equal to 1 megagram, which is 1 million grams, but nobody uses megagram. Instead, we just use ton. That is T-O-N-N-E, not the old time ton under the British system. The above table is used the same way for mass as was used for length in the previous video. So let's concentrate on mass for the next few examples. Convert 305 grams to kilograms. Now this is fairly easy because you already know that kilo means 1,000. So if you are going from grams to kilograms, you would divide by 1,000. However, let's follow the principle that we were learning. We are here, our base unit, grams. We are going up here, kilograms. The factor difference is that 3 minus this 0. So you get 10 to the third, which is 1,000. So it takes 1,000 grams to make a kilogram. We will therefore divide, since we are going from a smaller to a larger, we're going from grams to kilograms, we will divide by 1,000. So 305 grams divided by 10 to the third power, that's 1,000. Grams per kilogram, we shift the decimal point 3 places to the left, 1, 2, 3, and so we get 0.305 kilogram. Example 2, convert 4,600 grams to kilograms. This is very similar to the one we just did. We are going from our base unit here, grams, to kilograms there. As I said, it takes 1,000 grams to make a kilogram because kilo means 1,000. So we are going from a smaller unit, gram, to a larger unit, kilogram. We will therefore divide by the factor difference. Let us see what the factor difference is. 10 to the third power divided by 10 to the 0 power. You subtract the indices. 3 minus 0, and you get 10 to the third. That's the 1,000 we were talking about. So we will have to divide by 1,000. Again, you shift the decimal point 3 places to the left. 1, 2, 3, and so we get 4.6 kilograms. So 4,600 grams, the equivalent for that is 4.6 kilograms. Example 3, convert 3,700 milligrams to grams. So we are at milligrams here, and we are going to grams here. Of course, by now you know milli means 1,000. So it will take 1,000 milligram to make a gram. So we will need to divide by 1,000. If you didn't know that, let's follow the procedure we were dealing with. 10 to the 0 going to 10 to the negative 3. Our factor difference will be 10 to the third, which is 1,000. We are going from a smaller unit, milli, to gram, base unit. So we will have to divide. So 3,700 milligrams divided by 1,000, 10 to the third power. Shift the point 3 places from where it is, 1, 2, 3, and we get 3.7 grams. Example 4, convert 4,650 centigram to hectogram. Now, I don't think CXC will ever ask you such a thing, as nobody seems to be using that again, but let us do it for the sake of this exercise. We are going from centigram to hectogram, which is here. From a smaller to a larger, we will have to divide by the factor difference. What is the factor difference? 10 to the second power divided by 10 to the negative 2. You subtract the indices and you get 10 to the fourth. So it takes 10,000, that's 10 to the fourth, centigram to make 1 hectogram. We will therefore have to divide by 10,000, which is 10 to the fourth. Divide by that, you shift this point 4 places because of this 4, and you get 0.465 hectogram. Example 5, convert 3.5 exponent 14 micrograms to tons. So where are we? We are at microgram here, and we want to carry all of that to tons, which is up here, which is actually megagram. So let's find our factor difference. As usual, we are going from a smaller to a larger. We will divide. Our factor difference will be 10 to the 6th divided by 10 to the negative 6. You subtract the lower indice from the higher one, and you get 10 to the 12th. So it takes that amount of micrograms, this amount, to make 1 ton or 1 megagram. And so you have to divide by 10 to the 12th. 3.5 times 10 to the 14th divided by 10 to the 12th. Well, this is already in the format here of standard form. This is 14 here, and that is 12 there. You are dividing, so you subtract the 12 from the 14, and you get times 10 to the second power, which really is 350 tons. That's example 5. Example 6, convert 25.6 tons to kilograms. So we are here, tons to kilograms. We already know that it takes 1,000 kilograms to make a ton. We can use that, or we could apply the principle. Our factor difference is 10 to the 6th divided by 10 to the third. You subtract the indices and you get 10 to the third, which is 1,000. 10 to the third is 1,000. It's 1 with 3 zeros. So we are going from a larger unit to a smaller unit. We will multiply by the factor difference. We multiply, and so 10 to the third, we shift this decimal point 3 places to the right. That 6 will take 1 of the space with 2 additional zeros. So we get 25,600 kilograms. Next, 8 convert 0.056 kilogram to milligram. We are going from a larger to a smaller. We will have to multiply by the factor difference. What is the factor difference? This 10 to the third divided by 10 to the negative 3. So we subtract the indices and we get 10 to the 6th. So it takes 1 million. 10 to the 6th is 1 million. It's 1 with 6 zeros. It takes 1 million milligram to make 1 kilogram. We are going from large to small. We will have to multiply by a million. So that's multiplying by a million. We shift this point 6 places to the right. 1, 2, 3, and add 3 zeros. So we get 56,000 milligrams. And that should suffice for conversion of mass. If you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. Now we continue with area. Consider this rectangle shown at left. It is 4 meters long by 3 meters wide. 4 meters long by 3 meters wide. If you are asked to find its area, and you would have learned this way back in grade 3 or grade 4, you will say area is equal to length times breadth. You will multiply the 4 meter by the 3 meter, and you will get an answer of 12 square meters. Now, I know you would say 12 meters square. Actually, that is 12 square meters. So the area is 12 square meters. That's the area of this rectangle you see on the left here. Well, just what is a square meter? If you were to draw 3 equally spaced vertical lines from the top side to the below side, you will get vertical strips, each 1 meter wide, 1 meter wide here, and 3 meters long. If you were to draw 2 equally spaced horizontal lines from left to right, you will get horizontal strips 1 meter wide by 4 meter long. So now this will be 1 meter and that will be 4 meters. Now let us put back all those lines, and what do we have? We could see 12 squares here, and each square is 1 meter by 1 meter. Each square. Therefore, this here is a square meter. That is how many pieces 1 square meter you could get out from 4 meter by 3 meter. Let us say that's a piece of board, plyboard. 4 meter by 3 meters, you could cut from it 12 1 square meter pieces. That is, each piece here would be a meter by a meter. And that is what we mean by a square meter. So that's how we get 12 square meters. Notice we say 12 square meters, even though we write it as 12 meter squared. Now let's consider one of that square meter that we were just looking at. 1 by 1. That is one of the little pieces of the 12 we just saw. What is its area? 1 square meter. Now, what is its area in square centimeters? Well, we know that 1 meter is equal to 100 centimeters. So its area in square centimeters will be 100 by 100, and we get 10,000 square centimeters. So if we were to draw lines 1 centimeter apart joining the opposite sides on this 1 meter piece of board here, we will get 10,000 squares, and each square will be 1 square centimeter. So let us say we draw 100 lines like this going across, and then another 100, actually 99 coming down. Then the intersection here will be 1 square centimeters. And how many of those will we get from this 1 meter? We will get 10,000. And this is what we want to look at specifically, that we have to square the linear measurement to get the square measurement. In reality, these lines will be closer, but you will get 10,000 of those little squares in 1 square meter. Now, if we take a second look at the table of factors we are using for conversion of length, those factors will need to be squared for area.